And now we have the next part of our discussion on temperature and heat. Last time we covered temperature change. In this video, we take a look at phase change. In the previous video, we talked about how when an object gains heat energy or loses heat energy, the object's temperature will change. But note that temperature change does not always happen when heat is gained or lost by an object. Under certain conditions, phase change will happen. And when we say phase change, we're talking about transition from solid to liquid, or liquid to gas, or gas to liquid, or liquid to solid. So under certain conditions, instead of temperature change, phase change happens. Under certain conditions, in fact, two conditions must be met for phase change to happen. First, the right amount of heat energy must be lost or gained by the object, and the object must be at the right temperature. Solid to liquid or melting will happen when a solid gains heat energy. So it must gain heat, Q must be positive, while it is at the material's melting point temperature. So the two conditions for melting to happen is the solid, the object must gain the right amount of heat energy, and the object must be at the melting point temperature of the material comprising the object. So the temperature of the object must be at the melting point temperature, and the amount of heat needed to be gained by the object must be equal to Q is equal to plus mLF. Plus because heat gain and the amount of heat needed is mLF, where m is mass of the object and LF is referred to as the heat of fusion of the material. Some books will refer to it as the latent heat of fusion, or heat of fusion of the material. So this is property of the material. Each material has its own value of latent heat of fusion, of LF. And the unit of LF is joules per kilogram. So again, for solid to liquid or melting to happen, the solid or the object must gain the right amount of heat. Q is equal to plus mLF, heat gain. And the object must be at the material's melting point temperature. Each material has a corresponding melting point. Reverse of solid to liquid or melting is liquid to solid transition, what we refer to as freezing. Freezing happens when a liquid loses heat energy while it is at the material's freezing point temperature. So again, two conditions. The object must lose heat, so Q must be negative, heat loss. And the object must be at the freezing point temperature of the material that comprises the object. T must be equal to T freezing point temperature of the material. Each material has a corresponding freezing point temperature. And the amount of heat that is needed to be lost by the object is given by Q is equal to negative heat loss. Q is equal to negative mLF. M is still mass of the object. LF is still the heat of fusion of the material. Heat of fusion is a property of the material that's associated to either the melting process or the freezing process. So again, liquid to solid will happen or freezing will happen if the liquid loses the right amount of heat while the material is at its freezing point temperature. On the other hand, solid to liquid or melting will happen when the solid, the object, gains heat energy, the right amount of heat energy, while the material or the object is at the melting point temperature of the material. Whether you have melting or freezing, you use LF, heat of fusion of the material. For most materials, the melting point temperature is the same as the freezing point temperature. For example, let's take for example H2O or water. The freezing point of water is 0 degrees Celsius. The melting point of ice is 0 degree Celsius. Melting point temperature, T melting. Freezing point temperature, T freezing. T melting is equal to T freezing. And this is followed for most materials. Next, we have liquid to gas or boiling. Boiling or liquid to gas transition happens when a liquid gains the right amount of heat energy while it is at the material's boiling point temperature. Again, two conditions. The right amount of heat must be gained, so Q is positive, and the material, the object, must be at the boiling point temperature of the material. T is equal to T boiling. Each material has a corresponding boiling point temperature. The amount of heat that is needed to be gained for boiling to happen, Q is equal to plus heat gain. So Q is equal to plus mLV, where M is mass of the object and LV is heat of vaporization of the material that makes up the object. And each material has a corresponding value of heat of vaporization. It's a property of the material. The unit for heat of vaporization is joules per kilogram. The reverse of liquid to gas or boiling is gas to liquid transition or condensation. Gas to liquid transition happens when a gas loses the right amount of heat energy, so Q is equal to negative, while the material is at its condensing point temperature. So again, two conditions. The object must lose the right amount of heat energy while it is at the condensing point temperature of the material that comprises the object. And the amount of heat that is needed to be lost is given by Q is equal to negative. Negative again, energy loss, heat loss. Q is equal to negative mLV. M is mass of the object, and again, LV is heat of vaporization of the material that makes up the object. So, LV is both for liquid to gas transition and gas to liquid transition, just as LF is for solid to liquid or liquid to solid transition. So again, gas to liquid or condensation happens when the object loses the right amount of heat while it is at the condensing point temperature of the material making up the object. And for most materials, the boiling point temperature is the same as the condensing point temperature. T boiling is equal to T condensing. Again, using H2O as an example, the boiling point of water is 100 degrees Celsius. The condensing point temperature of steam is 100 degrees Celsius. They are equal. T boiling is equal to T condensing. Now, water is a common substance. For water, we have the following values. The heat of fusion of water is equal to 333,000 joules per kilogram. The heat of vaporization of water is 2,256,000 joules per kilogram. And as mentioned, the freezing point of water is the same as the melting point of ice. It's equal to 0 degree Celsius. The boiling point of water is the same as the condensing point of steam, 100 degree Celsius. Preferably, you memorize these values, although you can easily look them up, but again, preferably, you memorize these values. It will save you some time, particularly say when it comes to the exams. You won't have to waste any time looking up these values if you already memorized these values. It is very easy to remember the phase change equations. You have equation for solid to liquid, liquid to gas, gas to liquid, and liquid to solid. But those phase change equations may be summarized as simply Q is equal to plus minus M L. And depending if you have heat loss or heat gain, Q will be positive or it will be negative. And depending on the type of transition, if you have solid to liquid or liquid to gas and so on, L will either be LF or it will be LV. So Q is equal to plus minus ML. Simply write down the states of matter as follows: solid, liquid, gas. If the transition is from solid to liquid or liquid to gas, so the transition is upward, at least in terms of this figure. So upward transition, you use positive sign. If the transition is downward in terms of this figure, so you have gas to liquid or liquid to solid, you use minus sign. You use the negative sign. And if the transition involves the lower half of the figure, solid to liquid or liquid to solid, L is just equal to LF. If the transition involves the upper half of the figure, so liquid to gas or gas to liquid, L will be equal to LV. So again, very easy to remember. Q is equal to plus minus ML. And that's it for now. That's it for our discussion on phase change. We'll continue our discussion on temperature and heat in the next video, wherein we take a look at conservation of energy in terms of heat energy. We have heat involved with temperature change, and we have heat involved with phase change. So we put all that together into just one equation. We have conservation of energy. So once again, that's it for now, and thank you for watching.